Okay, guys. What I want to do is go over some simultaneous equation models stuff with you again, because I think a lot of you struggled with it yesterday. So, not yesterday, sorry, last Thursday. So, what we're going to do is this is question one from the exercise that you were doing. We're going to just go through that together here, and hopefully, it will help you get a better handle on how to answer these questions. So the first thing we're going to do here in both part A and B is we're going to put together two equations that describe the wages of these two people, Matilda and Nathan. So our first statement in part A is Matilda earns $100 more than Nathan. So Matilda's wage is Nathan's plus $100 because she earns $100 more. Okay, so that's our equation number one. And in part B, we see that the total of both of their wages added together is $1,200. So we can turn that into an equation as well. And because we have our first equation in the form m equals n plus something, we're going to change this second equation into that same form by subtracting n from both sides. So this means that the plus n and the minus n cancel out and it just becomes 0. So we're left with m equals minus n plus 1200. Now we can go about plotting this information. So I've already drawn up some axes here, so I'm going to label the, I think I'm going to go up by 200s here. Did I do that right? Yeah. And we're going to use the hint that we're given in the question. N is the horizontal axis and M is the vertical axis. And I think along here I'm just going to do hundreds. Alright, now we need to put both our lines onto this graph. Now I'm going to use red for our first equation. M equals n plus 100. Now remember, our first point will always come from our y-intercept, our plus b here, which is at 100. Now this equation has a gradient of 1. Because the number here is a 1 in front of the n. And remember, that means rise over run. So to find our second point for this graph, we just have to make sure that we go up by the same amount we go across. So let's say we go across to 400 and up by 400 to approximately 500. And we're going to put a second point there. Now, what we can also do to find our second point is we can choose a value of n, let's say 1000, n equals 1000, and we can substitute that into our equation. So what this means is that when n equals 1000, m equals 1100. So we can also plot this point on our graph. Now, you don't necessarily have to go through both of these points. You can choose whichever method you prefer and just find one extra point. If you have 3, it does make it a little easier to draw a straight line. But only 2 points are necessary. Okay, now let's deal with our second equation. M equals minus n plus 1200. Now again, remember our y-intercept here gives us our first point always. Now in this case, our gradient is -1, so we need to go the same distance down that we go across. So we'll go across again to 400, and this time we're going down though, down to 800. And that'll be our second point. But we can also use our second method and say n equals 1000. Therefore m equals -1000 plus 1200, which is going to equal 200. So for our purple line, we have this point here when n equals 1000, m equals 200. Now we can join our lines. I haven't drawn this very well, but let's say it's something like that. Now we've finished drawing our graph, we can answer part D. Use the point of intersection of the two graphs to find Matilda and Nathan's wages. So the point of intersection is here. To find Matilda's, we read across from this point to here. It's not quite halfway, so I'm going to say it's 650. And we're going to read down to Nathan's wage. I think that's pretty much exactly halfway. So we'll say that is 550. Okay, I'm going to let you guys go on to tackling some questions of your own on page 149, exercise 5D. We'll start from question 3. If you were here on Thursday, you can start from whatever question you got up to on Thursday. And if you want a bit more help, we'll do this question on the board.